Hello everybody, I would like to welcome you to our 11th video in the pre-algebra playlist. And in this video we are going to go over what are known as numerical properties. So, one of the first definitions that we will go over is the commutative property of addition and the commutative property of multiplication. You have already encountered in the previous videos and in the examples that you have done by yourself that when it comes to addition and multiplication, the order does not really matter. So, for example, if you have three numbers that are being added together, then it doesn't matter if I add up the first two numbers together first and then add the third number, or if I reverse the order and add the second and the third number together and then add the first number to it. Therefore, the commutative property of addition basically tells you that the order in which you perform the addition operation does not matter. For example, if I have 5 plus 3, that is the same thing as saying 3 plus 5. Now, instead of writing numbers in this definition, I'm going to use variables because now you have gotten the hang of variables. So, if variable A represents some integer, or in this case it could be any number, and variable B represents another number, then A plus B is the same thing as saying B plus A. So this right here is the commutative property of addition. Similar to the commutative property of addition, the commutative property of multiplication tells me that the order in which I multiply two or more numbers together does not really matter. For example, if I have some number C that is being multiplied to another number D, then that is the same thing as saying a number D multiplied to number C. So for example, 3 times 5 will give me the same answer as 5 times 3. Now let's extend the commutative property of addition and multiplication into what is now known as the associative property of addition and multiplication. The only difference between the commutative property and the associative property of addition and multiplication is that with the associative property, there are grouping symbols involved. The associative property tells me that if I have the following expression over here, in which the letters E, F, and G all represent numbers, then I can rewrite the quantity of E plus F plus G in the following manner. So basically, if you have the numbers 1, 2, and 3, and you're adding them all together, like this over here, that will give you the same answer as this over here. So that is what is meant by the associative property of addition. Now let's quickly look over what is meant by the associative property of multiplication. So the associative property of multiplication tells me that if I have three numbers that are being multiplied together, such as H, J, and K, like this over here, then that is equivalent to them being multiplied in this order over here. So again, if you have three numbers that are being multiplied together, in this case, let's say 3, 4, and 5, like this over here, then that will give you the same answer if I multiply the three numbers in this order over here. Now for the next part of this video, let's go over something that is known as the additive identity. Now all that the additive identity really is that it's a basic property. And that property is that if I have some number, in this case, let's say that the number is denoted by the variable L, then L plus 0 will give me the same number that I started off with. So that can be represented as this over here. So I have my number L, and to the number L, I'm adding 0, so that will give me an answer of L. In this case, the additive identity is the number 0. To put this into perspective, let's say you have some number such as 4. So 4 plus 0 will give you an answer of 4. In this case, the additive identity is 0. Therefore, 0 is always the additive identity for any number. Now similarly, let's go over something that is known as the multiplicative identity. The multiplicative identity is the number 1. So for example, if I have some number which I represent as the variable m, then m times 1 will give me the m. So if I have some number such as 5, and if I multiply 5 by 1, then 5 times 1 will give me 5. So since I want to end up with what I started off with, the multiplicative identity is the number 1. Now, in most classes or math classes, you won't hear anything such as the subtractive identity. I don't even know if that's a word or not. or anything such as the dividitive identity or not, whatever. Even though those things don't really show up in textbooks and whatnot, you need to realize that if they were to exist, the identity of subtraction would be 0 as well. Because if I have some number, let's just say 4 again, and I want to end up with what I started off with, then 4 minus 0 is the only operation that I can perform so that I will end up with what I started off with. Similarly, with division, if I have some number such as 5, then the only way that I will end up with what I started off with, in this case the number 5, is if I divide by 1. Now let's go over one more property in this video, and this one is really a big one. This one is known as the distributive property. So the distributive property is basically telling you the following. If you have some number m and you're multiplying that number n to the quantity of the sum of two numbers n plus p, then this is the same thing as saying m times n plus m times p. To verify this property, let's say you have something like this over here. So 2 times a quantity of 3 plus 6, according to the distributive property, will be the same thing as saying 2 times 3 plus 2 times 6. Now let's try it out. So 2 times 3 will give me a 6, and 2 times 6 will give me a 12. So if the answer over here is equal to 18, then the distributive property is true. In this case, 6 plus 12 will give me an 18, and if I don't do the distributive property, and I use the method of PEMDAS, then I get 3 plus 6 on the inside first to give me a 9, and then I evaluate 2 times 9. And since 2 times 9 is 18, and 18 over here is the same 18 over here, the distributive property holds true. What you can do now is that you can extend the distributive property with the subtraction in the parentheses. So if you have something like this over here, then I can find the answer again using the distributive property. The only difference will be that instead of a plus over here, I will have a minus. So m times the difference between n minus p is the same thing as saying m times n minus m times p. Now let's use the distributive property as a tool to help us simplify variable expressions. Let's say I have the following variable expression. So if I want to further simplify negative 10 times the quantity 3x minus 2, all I really need to do is follow the distributive property up here. In this case, I can rewrite negative 10 times the quantity of 3x minus 2 using the distributive property up here like this over here. Now all that is left to do is to evaluate the variable expression. So negative 10 times 3x can be simplified by simply multiplying the numbers together. So negative 10 times 3 will give me a negative 30. And since I'm multiplying that by the variable x, I simply write the x by it. So negative 10 times 3x is the same thing as saying negative 30x. Now I put the minus over here again, and now I simply evaluate negative 10 times 2. You know by now that negative 10 times 2 will give me a negative 20. Now all I need to do is evaluate negative 30x minus a negative 20. Now you learned a few videos ago that if I'm subtracting a negative number, that is the same thing as saying I'm adding the number. So negative 30x minus negative 20 is the same thing as saying negative 30x plus 20. So there it is. My final answer of negative 10 times 3x minus 2 can be simplified as negative 30x plus 20. Now let's do one more example like this over here. Let's say I have something like 5 times the quantity of 2x plus 7. In this case, I can use the distributive property up over here to rewrite this variable expression like this over here. In this case, 5 times 2 times x is the same thing as saying 5 times 2, which is 10, times x. And 5 times 7 is the same thing as saying 35. So there it is, my final answer of 5 times the quantity 2x plus 7 It's the same thing as saying 10x plus 35. Now let's use the magical powers of the distributive property to help us multiply two numbers together quickly and efficiently. So let's say I wanted to evaluate the product of 15 and 105. So I can write this down like this over here. 15 times 105 might take up a little bit of work, but if you think about it, I can use the distributive property to rewrite 105 and that is inside the parentheses as simply 100 plus 5. So I can rewrite the product of 15 and 105 as the product of 15 and the quantity of 100 plus 5. So I can use the distributive property up over here to come up with this over here. Since 15 times 100 can be rewritten as 15 and then simply adding the two zeros at the end of it like this over here, and 15 times 5 by now you know is 75. I can reach my final answer quickly and efficiently by simply adding 1500 and 75 together to give me 1575. Now lastly, let's see an example of reverse distributive property. So let's say I had something like this over here. Now, if I want to simplify 8x plus 8y plus 8 times 3 plus 8 times 6k using the distributive property, you might be wondering how you would be able to do so. Well, if you think about it, the distributive property over here is just a basic guideline. It adds up two numbers, or basically two variables together, n and p. But what would happen if you had something like this over here? All you would need to do now is do m times n plus m times p plus m times j. It doesn't matter how many terms you have inside the parentheses, you would perform the same type of operations like you did with the n and the p over here. So all we need to do now is figure out what our m would be in this big expression over here. We need to figure out some common number or some common variable that we can basically take out, or as it is known in math, factor out of this expression. In this case, we notice that we have an 8 over here, 8 over here, 8 over here, and another 8 over here. So it is safe to assume that we will be taking out an 8 from this expression over here. And when we do that, we can simplify this big variable expression over here like this over here. We can start out by writing the 8 on the outside, and then we write down the individual terms without the 8 on the inside. So if I take away 8 from this 8x over here, all I will be left with is the x. Then the plus stays the plus. Now remember, if this was 8x minus 8y, I would simply write a minus over here. So I have 8y over here, and when I take away 8 from it, or basically if I factor out 8 from 8y, I'll be left with a y. Now I have 8 times 3. If I factor out or take away the 8, I'll be left with simply a 3. And lastly, I have 8 times 6k. If I take away 8 from 8 times 6 away, I'll be left with 6k. So this right here is my answer that I'm looking for. Now, there is no official word such as a reverse distributive property, but we just exercised it right over here. So that's it for this video, and I hope you enjoyed it thoroughly. I hope you keep on working hard, and I'll see you in the next video.